All right, this is part two of the Huff and Puff um, VFO stabilizer. And if you want to find this stuff, now in this case, this is Hans Summers, 2004. I saw a picture of this guy, and he looked really young. And I'm like, what did I do? So I went back and looked through, and it was the original guy that come up with the idea of this type of phase lock loop, or whatever you want to call it. His name was Kraus. So both Hans and Kraus are sort of like Swiss or German. And I'm German and English myself, but somewhere along the line I got lost. And then when I saw this circuit, I'm thinking, oh, that's a piece of cake. I'm going to wire it up. So I ordered the chips. After a month of not ordering anything, I ordered the chip. It's a 74HC 4060, I believe. Okay, so I didn't have any of those. I have everything else, but I didn't have one of those. And then the guy uses a watch crystal. Basically, I had one of them at one time in one of the bins. Can't find it, so I had to order those. And of course, when you buy some of this stuff, you have to buy 10 or 5. And when you buy 5, the price actually goes up. So they know they work their psychological thing up. He needs just one. I'll sell him 5 for a lot of money, or 10 for next to nothing. Well, either way, they make their money on you. So both those items are coming today. Now, if you watched the last video, I was salvaging stuff, and this is one of my favorite type of perf board colors. Okay, it doesn't show the flux after you clean it. It looks very nice, and this was a piece of perf board. This has been repurposed. That's why I'm having trouble getting all the parts on here, because I'm working with a certain size. And in here I have a Zener diode. 9 volts comes in and supplies the chip with 5 volts. All right, so I had to add that in there. So it's basically self-contained. So I tell you, I spent a lot of time reading about Huff and Puffs and looking at different circuits and following back. I think it was 1973, I said it started. The guy Kraus started it. So along the way he died. Other people picked it up. So basically, you got an output from the oscillator, and it's going into a counter. And the counter is running at a certain frequency, and a certain amount of pulses come out. And if the oscillator goes too fast or too slow, it affects the output voltage. You'll have to read up on it. I'm not going to try to explain it because I'm having trouble with it myself. So here's the circuit, and I follow through, and then I found the page for this circuit. See, when you're on the internet, it takes a while. If you have let me make sure this is in frame. You have a circuit, you find one guy's page, but he doesn't tell you where it came from. Okay, he's become a library. He wants you to click on his web page because maybe he's selling something. So I start building this circuit, and I'm saying to myself, when I read to get to this circuit, I was looking for something that would do anything from 1 megahertz all the way up to 30 megahertz. Now, the people that take these circuits and then load them up on their page, they're gonna show the circuit in the most positive light. So I'm building this thing, and I'm worried about these two capacitors down on the bottom. Let me make sure I'm in the frame. I didn't have 22 picofarads, but I found out with this chip you can use up to 37. I found some 27 picofarads, and there's one more up here. And I was worried about this because this sets a certain frequency. Am I in the frame? That I know to be careful. So I'm putting that circuit by itself in one spot. But I did find the actual article for this thing. And this is a little iffy, this circuit, okay? So I'm into this thing now, many hours, thinking about it, salvaging the parts, actually wiring it up. I have 3 wires left to put on this. 3 parts, 3 wires. 2 parts, 3 wires. And this will be done and ready to go. And the parts are coming today. But I found a page that goes with the circuit. And he starts telling, this is critical. This could be critical. I'm like, oh, what did I get into? I don't want that. Okay? But I'm now in the circuit, or into the what you would say, the rabbit hole. And most of these guys that make these circuits, this is what you get. 2 VFO. Well, I know 2 VFO varicaps, so you have to install a varicap in there. Well, most of them don't tell you what the value is. Now, I've seen one hookup where the guy takes a varicap and it goes out to the circuit, and he's got a coupling capacitor. Because remember I told you, if you had a varicap that's 100 picofarad and you need a varicap that's only 50, you can put a capacitor in series with it. And that's what this one guy did. So that's what I'll be doing. In order to vary the amount of capacitance to the oscillator from the varicap that I'm going to be using, I'm going to couple it with a series capacitor. And if I need more frequency change, I increase the value of that capacitor. Because you'll go crazy changing different varicaps. Okay, from a 25 to a 50 to a 75. It can be done using the coupling capacitor, but nobody shows this stuff. Now I've built oscillators using varicaps. I know how they're hooked in the circuit, but they assume you know this stuff, and I assumed, an ass out of you and me, I think the word breaks down to as assume, but I assumed that this guy, when he put this schematic up on the internet, it was pretty well figured out. Okay, I didn't want anything words critical in it. And then the other thing too is he mentions kilohertz, 60 something kilohertz as the output frequency. I'm like, that's not what I was told when I grabbed this circuit. I was told it was from 1 megahertz to 30 megahertz. So this whole thing might not even work. Okay, and that's where I'm like, I don't need these kind of circuits anymore. I like experimenting, but not at the level where the thing doesn't really work right. Okay, now the person that mentioned that this circuit might not be, he mentions the 2 or 3 chip version, and I'm like, okay, here we go. Now the original, going way back to the original guy, would be not Hans. Oh wait, I'm forgetting now. It's not Hans, it's Kraus. And Kraus, he had a whole bunch of 7490s to divide the oscillator down to get to 1 hertz. And it just says on the schematic, basically dividing circuit, and that's where it enters. But he doesn't show how many 7490s you need. He mentions he uses a 100 kilohertz crystal, but doesn't show how that's wired in the circuit. That I know how to do, but I'm looking at these circuits as a beginning experimenter, and this is not what this is for. Now, a lot of you say just use a DDS or whatever it is, a phase lock loop module. I wanted something really simple, okay? And it's for a receiver that I'm going to build, maybe in the winter time. But I like to do all these little tiny experiments and then slowly morph them all together and create a radio. Like that I showed you that front end I built. And that front end's only good from like say 3 megacycles to 10. Let's just say 3 to 10. And all those other bands, it's not going to work. Okay, it's not made. It's made for several bands, but it's not made to be a regular shortwave radio where you have 10 bands or whatever frequency range. I built it for a radio for myself for just before bedtime. The frequencies that are hot at night, that's what it's being built for. All right, and that's the project. And I think about it, and I slowly build it, and then it gets done. Okay, but this thing here, I was all psyched. I see this thing, and it was really nice. And this one guy has a page that he just dedicated to storing all these different Huff and Puff circuits, but he doesn't reference you back to where they came from. And that same thing happened with CNC stuff, with the driver boards to drive the motors. These guys were constantly building websites up using stolen stuff. One guy, all his stuff had patent on it, on the pictures, patent, copyrighted. But he had all my stuff on his website, and he never asked me if he could display any of my pictures. But he took pictures off other people's websites, posted them on his, but all his drawings, which were junk, his ideas were stupid, he put patent and stuff. He's nuts. But anyway, no referencing back. So you find this guy, and you see your work, but you don't see any link back to your website. And that was some of the stuff that will aggravate you. And other people, it's their ego. They're trying to do certain things with other people's work. Now, if you ever watch the video that's reversed, the video is reversed, and that video has been stolen from somebody else. So the guy runs it through a thing that affects the sound, or he reverses the video, or he puts a little man in the right-hand corner that's like talking. And what that does is it keeps the copyright machine from picking up on the video that it's been lifted from somewhere else. Okay, there's a lot of nonsense going on, but I think I fell into a really bad rabbit hole. I don't even know what frequency range this thing's gonna huff and puff and stabilize. You know, every one of these articles that I found are missing vital information, and I just wanted to tell you that in this video. So if you go down this route, you know, and you'd say, well, what oscillator would you use? Well, I'm using a Franklin oscillator, and it's stable enough to do shortwave stations. But on sideband, as you're listening, you have to touch it up. And after it's on a while, it does stabilize pretty good. But the one that I have with the varactor, it keeps drifting. Okay. Now, there's one guy on the internet that says that the varactors, they're twice as stable as a regular tunable capacitor, or 10 times better. And then you find a page where this guy's got all these thermistors hooked to a varactor just to stabilize it. I'm like, well, what's the real truth? Well, I built both oscillators, and I found that the varactor drifted. Okay, that's my own, you know, and it was in a metal box, the whole thing. I don't know at this point. And then there's the purist guys. They take an old-fashioned oscillator and they build it into a steel box, and they're explaining all your components have to be an NPO. Well, anyway, there have to be negative temperature coefficient caps, and I think it's NPO. There's so many three-letter NPO, I'll say. There's so many letters and stuff you have to remember in electronics, and I'm dyslexic. And certain things I can remember certain days, certain times and stuff. But in other words, he tells you use this and use that, and that's basically what my Franklin did. But my Franklin's got a very wide range of frequency, and that causes some instability. Okay, but the Franklin puts out pretty damn good sine wave, and a lot of these circuits, you notice they're showing you a square wave. Okay, let me make sure that's in the frame. They're always showing you a square wave, and that bothers me because I know a square wave, it puts out multiple frequencies. And then I found an article saying, well, these stabilizers create FMing and all other kinds of problems. And then another article says they've checked on it and it doesn't. So who do you believe? Okay, so after I start building this thing, I'm taking breaks. I read the texts, different things that I've collected, and you start seeing that this thing is bug-ridden, okay? And I would never publish anything this bug-ridden, okay, myself, okay? But other people are different, you know, they get some, and the one guy, like I said, his name was Kraus, and he did it with a bunch of chips, and he told you, and it was in like German or Swiss, and someone translated it into English. So I found his text, the guy who translated the text, and as I'm looking through all this stuff, I said, this is a great experiment, but I wanted an experiment, but not to go that deep that I fall into another rabbit hole. And I'm in another rabbit hole. And I just wanted an oscillator that when I tuned it to a frequency, it would stay there, okay? And I have those DDS units and stuff, and they just put out all kinds of noise because there's a microprocessor in there that's creating the sine wave. It's synthesizing the sine wave. And it's not even a sine wave. It's some type of hybrid square wave, and at some frequencies it just looks terrible. Okay, and I found that when you put that type of sine wave into a mixer, you're going to get I won't say artifacts. You're going to get other signals in there that don't belong. And I want to tell you one real cute thing I saw. At first, I was looking at it. A guy took a Radio Shack, let's call it a DX160. I think it was a 159. And it's a single conversion shortwave radio from back in 60s, 70s. They sold them. And he put two of those frequency counters on the front of it. And you say, why? Well, it's a single conversion radio. So you actually can pick up, through the antenna, you can pick up a station that's 455 above the frequency and 455 below the frequency. So in other words, when you tune a frequency, you could actually be seeing the radio showing you an image of the same frequency. By having the two displays there, he can see the one he wants to see, and he has a warning that if he sees the frequency on the other frequency counter that's out of the band, that he knows he's getting an image caused by the radio itself. I thought that was pretty cool, because some nights when you're DXing, you're picking up a station, and you're like, why is it over here? Never thinking that I didn't notice when I was a shortwave listener back in, say, just out of tech school. I didn't realize the receiver would produce a signal that really wasn't there. Where you first run into this is if you're close to New York City and you're on long wave, you'll find AM broadcast stations on the long wave band. And somebody asked the teacher in tech school about those, and he just made believe he didn't hear the question. But those stations are actually caused by overloading. The station gets in the receiver, and it beats with the oscillator, and you get stations that are 455 below the actual frequency. And in some cases, a shortwave radio, some of them don't use 455. They might use a 1.5 megahertz IF can. So those images would actually be down in the long wave. So as you're tuning along long wave, you're hearing all these AM stations down there that don't belong there. Now, if you had the dual frequency counter on the receiver, you would see that when you pick that up, that it's off by 455 or whatever the IF is, and you'd say, okay, that's an image I'm picking up. But I didn't understand a lot of that stuff, and a lot of times I'd be going along on the band, and I really didn't understand, like shortwave bands, the stations are within certain areas, and I'd be going along, and I'd find a station, and I'd be listening, waiting for it to ID, and it would be like Voice of America, and it wouldn't be in the right place because the receiver was being overloaded, and it was showing me that station was there, and it really wasn't on that frequency. And then I'm trying to figure out what the station is, but it's actually somewhere else also on the dial. And Voice of America used to drive me nuts. Our country used to transmit, like, say, 15 signals, 15 different stations at the same time, and Russia did that too. The difference with Russia is their carriers had like a hum noise in it, like a 50 cycle hum, and you knew it was Russia, but was it Sofia, Bulgaria? Was it one of their satellite countries? And it would be the same propaganda stuff, and you tune it, but by hearing that hum noise from their carriers, you knew it was a Russian station. But yeah, I spent a lot of time on radios and thinking about them, and I saw these articles, and I got excited, you know. I wanted to build something that wasn't complicated. Now, if you look at the schematic, it's very misleading. When you try to build the circuit and lay it out, it was a little bit more. And on the back, I try to be real neat. Okay, but in other words, there's a lot more parts on this circuit than when you look at the schematic. Okay, and they leave off the B plus. You know, the top of these capacitors here has to go to here, which is to the regulator. So, you know, that makes when you leave these wires out that have to be there, It makes the schematic look less complicated, especially if you VFO to vary caps, okay, VFO in, and then they're showing you it's got to be grounded to wherever it's coming or going to. I know some of you guys know that, some of you guys don't. I had a guy one time, we were building TV decoders, and he was a tech at work, and he made more money than I did. And I gave him a schematic, and he didn't hook the ground. These are grounds. He left them all off. He didn't know where they went to. I was like, oh, brother, I didn't say nothing. And he knew I was thinking something, but I wouldn't say it to him. But it's amazing. Everybody has gaps in their, what would you say, gaps in their knowledge. And that's why I told you on a couple of videos I did, I never heard of it. I never heard of something. I never heard of Huff and Puff until I kept reading and I bumped into it. There's things in electronics, you're not going to know everything, okay? And I was watching Fran Labs. I don't know if you watch her stuff or Shango. And you can notice when they're getting into an area that they're not that familiar with. And on Fran Labs, it's actually a guy, but he or she was saying that you got to build circuits with single components instead of buying modules. And there was something else that he or she said that I agreed with, but that's her opinion now, or his opinion. As you get older, you think everything should be the way you had it. I'm not like that. I like old school stuff, but I also understand where there are people that just like to take a bunch of modules and wire them together with really long wire and put it on YouTube. Okay? There's a lot of that. And I look at them like, oh, brother. And a couple of the guys, if you watch the videos, were saying you want to keep the wires as short as possible. Okay? But when you're in a hurry to do something and get it working and then put it on YouTube, that's not going to happen. But, yeah, and some of Shango's stuff, I watch his repairs, and sometimes I'll see him say something, I'm like, that ain't right. And then he catches himself. He does catch himself. And, you know, he makes mistakes because he's repairing something live. And he'll have a certain theory on what's wrong based on experience. And then he'll go down a rabbit hole for a few minutes. And then, you know, he'll turn the video off and go get the schematic. And then he'll tell you, I was wrong. Blah, blah, blah. Some other guys don't do that, man. They have a working receiver. They know what's wrong with it. And then they sort of fix it on the with the camera running. You know, so you're watching and you got, boy, this guy's really smart. Now, he already knows what's wrong with the radio. And you can tell the difference when you're knowledgeable, the way a person approaches a repair. And with me, I know from years and years of how people abuse stuff that the first thing you check on a portable radio is the speaker working? I don't troubleshoot down to the speaker. I test the speaker first. I make sure the volume control isn't broken. Okay. Also, I look at, is the volume control replaceable? And if it's not, I don't touch that radio. Why would I fix the radio and then find out I can't find a volume control for it? And if a battery has leaked through a radio, it's garbage. I had a guy one time gives me a remote control for his with the remote control for his garage door. And I take it home and I take it totally apart. There's a battery leaked. I clean it up. I go get a battery. I bring it over to him. It's not even for that remote, for that unit. There was a household of idiots. Okay? That's all I can say about that family. They would give me a remote control for a VCR that didn't work. I take it home, change the battery. I check it out with, I have a card that when you hit it with an infrared remote control, it glows. And I go back over there and then I realize the remote control doesn't match the unit itself. So then I go look and I find the remote control. Okay, so what they did was they couldn't find the remote control, so for some reason they went to the kitchen drawer and pulled out another remote thinking it should work, and then they gave it to me to fix. And that's the stuff I've totally detached myself as best I can. But I'll tell you a real quick story. It's sort of funny. I know a lot of people here now. 14 years, I go out for these long walks. I bump into people. I see them. There's only a bunch, there's say like 50 key people in the whole area that everybody knows. So I go walking, and I'm timing my walk from my house to the dollar store so I don't get wet. And I'm walking along, and a fire truck comes up, and they're talking to me, and I can't hear. And I'm pointing to my ears. I said, look, I can't hear you. I don't wear a hearing aid because I don't want this thing on all day long just to hear one or two people say something to me. And the fire truck was really loud, idling. And I look, and it's a girl I know. She's a fire person or a firefighter. Let's call her a firefighter. And she's really high up in the ranks now. So she sees me. I've known her since she moved here. And she starts talking to me, and I said, look, I point to my ears, and then she shuts the fire truck off. I walk over to her. At first, I thought they were coming to my area to fight a fire, and I'm like, I don't know. I don't know. Leave me alone. Leave me alone. Anyway, I go over to the truck, and she's talking to me. I know her. Okay. I went over, when she bought my friend's house, I went over and introduced myself. And she says to me, can you put some signs out for us? And I'm like, yeah. So they gave me some signs. It was for the chicken dinner. So what did I forget? Okay, I'm going to tell you. I forgot it's going to rain. So they give me these signs, and now I'm the type of person. You give me any task to do, I have to do it right away, or I can't enjoy the day or get anything that I want to get done. So I walk all the way to the opposite side of my neighborhood. I put one of the signs in, and it starts to rain. And I had an umbrella, but it was, anyway, I got wet. And then it was so funny. By the time I got to the dollar store, it had stopped. It's the typical, the screw job of life, you know. But, and then yesterday, I picked the signs up, and brought them back to her house. And I woke them up. It was 8 o'clock in the morning on a Sunday, but they were still sort of asleep. But I brought the signs back because I didn't want to think about the signs anymore. You know, I'm trying to build this thing. Okay, now I'm discouraged at this point. I found the page that goes with this, and this guy was doing a 60 kilohertz circuit signal. I'm like, that's not what I need. When I decided to build this, I was told 1 megacycle to 30, and I'm like, oh, but I'll get to see it work. Okay, and then I'll go searching again. But oh, son of a bitch, you know. And then I did find one of these that uses 2 chips and another crystal. But a lot of the ports are on this board now. Okay, I've salvaged from a lot of different projects to get these parts. So we'll see what happens. I think that's it. All right, that's it.